Let us practice substitution method for definite integral. Consider the integral from 1 to e fraction logarithm of x divided by x times 1 plus logarithm square of x. Well, too many logarithms. Let us use substitution to remove them. What about t is logarithm of x? Then, once again, when we compute the definite integral using substitution, we must recompute three things: the integrated function, the differential, and the limits. If x starts at 1, then t starts at logarithm of 1, which is 0. And when x goes up to e, then t goes up to logarithm of e, which is 1. It's a big mistake if you just copy the limits 1e here. No. These are the values for x, and these are the values for t, which in most cases will differ. So, now what about the function? Perhaps the differential. dt is derivative of logarithm, which is 1 over x dx. And 1 over x dx is fortunately here, this is this and this. So that will be dt. And in the remaining part, we must replace logarithm with t. Here we have fraction, logarithm x, which is t, and 1 plus square of logarithm, 1 plus square of t. So that was using substitution for this integral. Well, this can be done by the trick that the fraction where the numerator is the derivative of the denominator can be computed. But as a practice, let's use once again substitution. This times it would be nice to have a single letter, single variable in the denominator. This can be done when we use the substitution, say u is 1 plus t squared. Then the differential du is derivative of this. Derivative 1 is 0, derivative of t squared is 2t times dt. And once again, we must recompute the limits. If t starts at 0, then u starts at 1 plus 0 squared, which is 1. And when t goes up to 1, then u goes up to 1 plus 1, which is 2. Then 2t dt is almost here. Perhaps if we multiply by 2 and divide by 2, then the differential 2t dt is here, and this is du. And we have 1 plus t squared in the denominator, which is u, and only 1 here. Well, and at this point, we can easily find the antiderivative, which is logarithm absolute value of u. We close into square bracket, and we write the limits from 1 to 2. So when we substitute the second limit, the upper limit 2 for u, we have logarithm of 2 minus logarithm of 1. Logarithm of 1 is 0, so the result is logarithm of 2. So when we use the substitution method for definite integral, don't forget to recompute the limits. Perhaps other alternative would be to forget the limits and compute the antiderivative, but then we must go back from u to g and from g to x, and then we substitute the x limits for the antiderivative in x. But this is easier, this is shorter in most cases.